Linear scaling is an important skill to have when we work with analog signals for programmable logic controllers. In this module, we're going to review the equation of a straight line and refresh some of the math skills we will be using. If you are already familiar with the equation of a straight line and don't need to review, then please skip forward to the next module. The straight line equation we will be using is y equals mx plus b, where m is the slope of the line, or rise over run, and b is the y-intercept, where x is equal to 0. In the example on the left, we have two different lines represented. The red line and the blue line both have a y-intercept of 0, so they both cross through the origin point. However, these two lines do have different slopes. Picking a convenient point on the red line, I find a rise of 3 and a run of 3 when I measure from the origin. So therefore, I have a slope of 3 divided by 3, or 1. So for this line, the equation is y equals x. But for the blue line, the rise is 2 for every run of 1, so therefore the slope of the blue line is 2 over 1, or 2. So this makes the equation for the blue line y equals 2x. In the example on the right, we have a pair of parallel lines, that is, two lines that share the same slope. However, they do not have the same y-intercept. The red line intercepts the y-axis at 0. Therefore, the red line's equation is y equals 1/2 x. For the blue line, we intercept the y-axis at 3, for an equation of y equals 1/2 x plus 3. Using both the slope and the y-intercept, we can write an equation that describes any line other than a purely vertical line that goes straight up and down. We did all that to get to here, so let's make this equation do some work for us. With this equation, we can plug in a value for x and determine the corresponding value for y. If x is equal to 1, then y is equal to 1/2 times 1 plus 3. So therefore y is equal to 1/2 plus 3, and y is equal to 3 and 1/2. If we look at the graph, we can see that where x is equal to 1, y is indeed equal to 3 and 1/2. If we plug in a value of 3 for x, then we get y equals 1/2 times 3 plus 3, which is equal to 1 and 1/2 plus 3, which is equal to 4 and 1/2. Again, the corresponding graph agrees with our calculation. When we apply the equation of a straight line to analog scaling for our PLC, we will be developing an equation that allows us to convert between one range of data and another. For example, we will learn to calculate the expected output from a 3 to 15 psi I2P controller as produced based on a signal from a 4 to 20 milliamp output on the PLC.